The cswip 3.1 Welding Inspector course provides comprehensive training on welding inspection and quality control. It covers essential topics such as welding processes, inspection techniques, codes and standards, and the duties of a welding inspector. The main objectives of the course are to understand factors influencing weld quality, recognize characteristics of welding processes, interpret drawings and symbols, set up and report on inspections, assess welds to acceptance levels, confirm material compliance, and prepare for the Level 2 examination. The course includes theoretical and practical training, followed by a closed-book examination. Candidates must provide required documentation and pass all sections with at least 70% to be certified. Certification is valid for 5 years, with renewal and prolongation requirements. Welding inspectors are responsible for quality control activities to ensure welded items meet specified requirements. Their duties include understanding QC procedures, conducting visual and non-destructive inspections, and ensuring compliance with standards and codes. According to ISO 17637, visual inspection requires proper illumination, access, and the use of inspection aids such as gauges and magnifying lenses. Inspectors must be familiar with relevant standards and have good vision, checked annually. Inspection is required before, during, and after welding. Each stage involves specific checks, such as material verification, equipment calibration, process monitoring, and documentation review. Welding inspectors use various equipment such as welding gauges, measuring tapes, magnifying lenses, and multimeters to ensure accurate inspection and compliance with standards. Accurate documentation is essential. Inspectors must record inspection results, including material details, weld types, acceptance criteria, and any imperfections. Records may be checklists or detailed reports as required by contract. Understanding welding terminology is crucial. Key terms include weld, joint, brazing, and various joint types such as butt, T, corner, edge, cruciform, and lap joints. Each has specific definitions and applications. A completed weld consists of parent metal, filler metal, weld metal, heat-affected zone, has, fusion line, weld face, root, toe, and excess weld metal. Each feature affects the weld's performance and inspection. Proper weld preparation is vital for quality. Common preparations include open square, single, double V, U, J, and bevel types. Each preparation has specific angles, root faces, and gaps, affecting penetration and strength. Welding positions include flat, horizontal, vertical up, vertical down, overhead, and more, as defined by ISO 6947. Techniques such as weaving and stringer beads are used to control weld shape and quality. Welding imperfections are deviations from the ideal weld. According to BSE and ISO 6521, they include cracks, cavities, solid inclusions, lack of fusion, penetration, imperfect shape, and miscellaneous imperfections. Cracks are serious imperfections that can occur in weld metal, has, or parent metal. Types include longitudinal, transverse, radiating, crater, and branching cracks. They may be hot, cold, or lamellar tearing. Cavities such as gas pores, wormholes, and surface porosity are caused by trapped gases during solidification. Proper cleaning, correct parameters, and shielding gas control help prevent these imperfections. Solid inclusions such as slag, flux, oxide, and tungsten can be trapped in the weld metal. Causes include poor cleaning, incorrect parameters, and electrode issues. Prevention involves proper technique and preparation. Lack of fusion and penetration occur when the weld metal does not properly bond with the parent metal or between weld layers. Causes include low heat input, poor technique, and incorrect preparation. Common shape and dimensional imperfections include undercut, excess weld metal, excess penetration, overlap, linear misalignment, angular distortion, incompletely filled groove, irregular width, and root concavity.